Before implementing any critical thermal processing step, you need to confirm that the oven you are using is delivering the temperature uniformity required for your process. A 9-point uniformity test that measures temperature in every corner as well as the center of the oven will ensure that the temperature throughout the oven remains relatively constant. This test is normally conducted prior to putting the tool into service, after any invasive service or repair work that could affect the heating airflow circuit, and annually or more often depending on the process risk and value of the load. The first test should be performed with no load to verify that the oven is performing to specification. A second test with product loaded should also be conducted. This test will help determine proper oven loading and airflow. In this demonstration, we will be conducting the test with no load. To complete this test, you will need 9 thermocouples and a 9-point temperature data logger. Be sure to use certified thermocouples that have not been degraded with repeated use. For the best accuracy, we will use brand new thermocouples. Make sure that the insulation is not frayed or damaged to avoid bare wires making contact with metal on the oven. The tip of the thermocouple should be welded, not twisted together. The best practice for getting the thermocouples into the interior of the oven is to insert them through the oven port if one is available. If a port is not available, the next best option is to run the wires through the exhaust port on the back of the oven. Try to avoid running the thermocouples through the door because it causes leakage points past the door seal. At high temperatures, take care that the point where the thermocouple wires enter the oven remains constant. Changing this hot-cold transition point can cause shifts in the calibration. Inside the oven, position a thermocouple in each of the 8 corners of the oven. Loosely wrap the thermocouple around the oven rack and position the tip of the thermocouple about 3 inches away from any oven surface. Mechanical stress can cause a shift in the calibration of the thermocouple, so be sure to avoid any sharp bends. Position the final thermocouple as close to the center of the oven as you possibly can. While installing the thermocouples, we were sure to mark each one according to its location inside the oven, so that when we take the readings, we know where we are getting them from. Keep the recorder away from the heat of the oven to avoid cold junction compensation and significant measurement errors between input channels. Make sure any measurement instrument is properly grounded. Failure to use a proper 3-prong power cord can make the measurement instrument more susceptible to induced electrical noise. Also be aware of any equipment in the vicinity that is prone to causing high levels of electrical noise, such as welding equipment that intermittently switches high power levels on and off. Once the thermocouples are all placed and connected, set the oven to the temperature to be used in the process. The oven should then be allowed to stabilize for a minimum of 30 minutes before measuring. If you find that your oven is not delivering the expected uniformity, there are a number of things to check that could be affecting the results. Check the door seals to make sure you are getting a proper seal. Examine the louvers to make sure they're not blocked. Ensure that the recirculation fan is working properly. Check for problems with the fresh air and exhaust damper. Your chamber pressure needs to have neutral to slightly positive pressure to achieve expected uniformity. If that doesn't address the problem, it could be poor wall insulation causing the oven to lose too much heat. Now that the test is complete, we can shut the oven down. Be sure to let it completely cool before going inside to remove the thermocouples.